So hello GW soldiers, very good evening to all of you my dear friends. I hope you are well and your study is also going well. So today we will discuss 10 to 15 questions of supernetting, and we will also discuss the concept of supernetting in classless addressing. Okay. So in the last class already we covered the IP addressing and subnetting concept. So in this class we will cover the supernetting concept and we will solve 10 good quality questions of supernetting. So your first chapter IP addressing, subnetting and supernetting will be revised. Actually most of the students were saying, sir, please solve some supernetting questions, because in the last year GATE 2022 there was one 2 marks question of supernetting. So this year maybe they can ask a one good question from supernetting. So we will cover all type of supernetting questions. So your entire concept of supernetting will be revised. Okay. So tell me that my audio, video, everything is fine. So we'll continue the session. So we will continue the session. So now this is the first question that you can see on the screen: 200.96.86.0, 200.96.87.0, 200.96.88.0, 200.96.89.0. So actually supernetting in classless addressing already we discussed one question. Okay, in the IP addressing and subnetting class. Okay, so now we will focus in this class, we will focus more on supernetting in classful addressing. Okay, so if classful addressing, if class is given, how we can apply the supernetting concept? Okay, this is our case. Okay, yes, fine, very good. Now we can say that, my dear friends, this is class C now. 200 means class C. Okay, so we have to check three conditions. What is first condition? First condition we have to check contiguous. First condition we have to check contiguous. Contiguous. So if it is classful addressing, how we can check that it is all these networks are contiguous or not? Okay, so 200 means class C. Class C have network ID 24-bit, host ID 8-bit. We know this thing that class C have network ID how many bits? Class C have network ID 24-bit and host ID 8-bit. Network ID 24-bit and host ID how many bits? 8-bit. Okay. So network ID 24 bits means first 3 octet. 3 octet network ID, 3 octet, 3 octet, 3 octet. So in the classful addressing, you can check that this is focus on because network ID 24-bit. Okay, so you have to focus on third octet. That third octet is contiguous or not. So this is 86, after that 87, after that 88, after that 89. Okay, and one more thing I also want to tell you one thing, that this is class C. Network ID how many bits? 24-bit. Host ID how many bits? 8-bit. Okay, so actually this is the first number now. Last this 8 bit, these 8 bits are representing host ID part or not? First number is 0. What is the last number of this? Last number means put all ones in the host ID part. So if we put all ones, so this is nothing but 8 ones means 255. So 86.255. So last number of this network will be 86.255. So next number will be 87.0. But we have no need to check like that, because it is classless classful addressing. In the classful addressing, network ID 24-bit. So it means we have to focus on 3 octet. 1, 2, 3. So this third octet, 86, 87, 88, 89. Yes, contiguous. It is true. If it is true, so we have to move second rule. What is the second rule of supernetting? Same size. Same size. All are class C. Yes, same size, 2 power 8. Class C host ID 8, how many bits? 8 bits. In this network, in this network, in this network, in this network, all the network have 2 power 8 IP addresses. Okay. Is it clear? Now. And number of networks, number of networks, number of networks, how many, my dear friends? Number of networks equal to, this is nothing but 4. So we can say number of networks is also 2 power 2. Okay. What is the third rule? First network ID must be divisible by total size of supernet. This is the third. First network ID must be divisible by total size of supernet. must be divisible by total size of supernet. Okay. Anyone can tell me what is the total size of supernet? Anyone can tell me what is the total size of supernet? Total size of supernet. If we combine all these four network, total size of supernet, total size of supernet. If we combine all four, this have 2 power 8 IP address, this have 2 power 8, this have 2 power 8, this have 2 power 8. Okay. So this is nothing but 2 power 8. How many times? 4 times. 2 power 8 plus 2 power 8 plus 2 power 8 plus 2 power 8. So what we can say, my dear friends? We can say this is nothing but 4 into 2 power 8. So 4 into 2 power 8, we can say this is nothing but 2 power 10. Is it fine? Any difficulty? Okay. Now, first network ID must be divisible by total size of supernet. So first network ID, this is 200.86.96.86.0. Let me show you here. 200.96.86. We have to divide by 2 power 10. If there is a 32-bit number, if we divide by 2 power 10, so it means last 10 bits represent remainder and remaining bits represent quotient. Okay. Now let's see. So we have to convert only last 2 bits into 0 and 1. Last 2 bits we have to convert into 0 and 1, remaining no need to check. Okay. So last 2, 86, 128, 0, 64, 1, 32, 0, 16, 64 plus 16, 64 plus 16, this is nothing but 80, 8, 0, 4, 2, 1, 1, 2, 3, 4, 5, 6, 7, 8. If I divide this number by 2 power 10, so last 10 bits represent remainder or not? Tell me one thing, that last 10 bits represent remainder or not? Yes. Remainder or host ID. So this is nothing but we can say remainder or host ID. So remainder must be 0. Divisible means remainder must be 0. Host ID must be 0. But last 10 bits are not 0. If last 10 bits are not 0, so we cannot apply supernetting concept. So supernetting is not possible, my dear friends. We cannot combine these 4 network into a one network. Supernetting we cannot apply. Supernetting we cannot apply. So tell me that, is it clear to everyone? Is it clear to everyone? Is it clear to everyone? So I will move to next question. If is it clear to everyone, so I will move to next question. If it is clear to everyone, so I will move to next question. Yes, sir, clear. Very good. Now, this is the next question that you can see here. What is this here? 198.47.32.0, 198.47.33.0, 34.0, 35.0. Okay. So we have these 4 networks given. We have to check that all these networks are divisible by, these are contiguous or not. All the 3 rules we have to check. First rule. What is first? Contiguous. First is contiguous. Tell me that it is true or not. Tell me that it is true or not. So it is also class C. It is class C or not? Yes, sir, class C. Network ID how many bits? 24 bit. Host ID how many bits? 8 bit. Okay. So network ID how many bits? 24 bits. We have to focus on third octet. 32, 33, 34, 35. It is contiguous. Contiguous or not? Yes, sir, contiguous. Now what is second here? Second is same size. Contiguous is true now. In classful addressing, we have to check network ID 24 bit. So we have to focus only for first 3 octet. Clear or not? Yes, sir. Same size. Now we have to focus on same size. Same size, yes, 2 power 8, because class C have host ID how many bits? 8 bit. So a number of IP address in one network, 2 power 8. Okay. And a number of networks how many? Number of networks, this is nothing but 4. We can say 2 power 2. Okay. Now, what is the third? first network ID must be divisible by total size of supernet. Tell me that. First network ID must be divisible by total size of supernet. First network ID must be divisible by total size of supernet. So how we can convert this total size of supernet? What is total size of supernet? Total size of supernet. Total size of supernet. So this is nothing but 2 power 8 plus 2 power 8 plus 2 power 8 plus 2 power 8. So this is nothing but we can say that 4 into 2 power 8. This is nothing but 4 into 2 power 8. We can say 2 power 10. Okay. Is it clear? 2 power 10. Now, first network ID must be divisible. How we can say that? If we divide this first network ID by 2 power 10. So last 10 bits represent remainder. Let me convert here. So this is nothing but 198.47.32. How we can convert 128? 6432. 16, 8, 4, 2. Entire octet 0. 1, 2, 3, 4, 5, 6, 7, 8. If I divide by 2 power 10, so last 10 bits represent remainder. Yes or not? Yes, sir. So this is nothing but host ID part. We have all zeros in the host ID part or not? Yes, sir. So this is also true. So it means we can apply supernetting. Yes. So what is supernet ID? Anyone can tell me what is supernet ID? Equal to first IP address. First IP address always. So this is nothing but 198.47.32.0. This is the supernet ID. How we can find supernet mask? How we can find supernet mask? Anyone can tell me how we can find supernet mask? Supernet mask. We know one thing, that total size of supernet. Total size of supernet. Total size of supernet. This is nothing but 2 power 10. So it means if total size of supernet 2 power 10, so host ID how many bits? 10 bit now. If total size of supernet how many bits? 2 power 10. So it means host ID is 10 bit. Because there is a one supernet, we have 2 power 10 IP addresses, host ID 10 bit. So what is network ID, my dear friends? Network ID is nothing but 32 minus 10. 32 minus 10, this is nothing but 22 bit. If network ID 22 bits, so in the supernet mask, how many ones we have? Supernet mask, 22 ones. Supernet mask, how many ones? 22 ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6. Remaining 0, 7, 8. Okay. Dot. 1, 2, 3, 4, 5, 6, 7, 8. So this is nothing but 255.255.252.0. Is it clear to everyone? Tell me. Is it clear to everyone? Now tell me one thing, that my dear friends, this is the supernet mask, na? It is better if I write here. This will be like that. Now I want to explain one more concept here. I want to explain one more concept, 255.255.252.0. It is class C, na? So you know one thing, that my dear friends, in the class C, what is the default subnet mask for class C? This is 255.255.255.0. This is default subnet mask. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is network ID we know, and this is host ID. So actually, in the subnetting, we take borrow from host ID, but in the supernetting, we take borrow from network ID. This is the small difference only. In subnetting, we take borrow from host ID, but in the supernetting, we take borrow from network ID. So actually, in the class C, subnet mask, how many ones? 24 ones must be minimum, na, in the subnet mask class C. Here, how many ones we have? 22 ones. So it means these two bits we have taken borrow. These two bits we have taken borrow, and these two bits are nothing but supernet bits. These two bits are nothing but supernet bits. Supernet bits equal to 2. So number of networks that can be combined, number of networks that can be combined, anyone can tell me? 2 power 2 yani 4. So it means we have combined 4 network. Yes, we have combined 4 network yaar. Yes, we have combined 4 network. We have combined 4 network, so we can find easily. Is it clear to everyone? So can I move to next question? Is it clear to everyone? So can I move to next question? Yes. This is another question, question number 3. Anyone can tell me? I'm giving you 1 minute of time. Yesterday I was not well, okay, down with fever and cold. But actually, my dear friends, I will discuss only quality content. No compromise with the quality. Okay. After attending this session, IP addressing, subnetting and supernetting, you have a full command and you can solve any question. Okay. You will not feel difficulty. I have arranged all the questions in such a way. And we will discuss today, we will discuss 11 to 12 questions of only for supernetting. Okay. Now, what is this here? Anyone can tell me this? First is true or not? First rule true or not? Tell me. Contiguous true or not? First. Contiguous true or not? Contiguous. Contiguous true or not? I'm asking from you. My dear friends, 128 means class B. 128 means class B. Or class B means network ID. How many bits? Network ID 16-bit. Host ID how many bits here? Host ID also 16-bit. Yes. Network ID 16 bits. So network ID must be contiguous na. First 16-bit we have to check. First 16-bit 128.56, 128.56, 128.56, 128.56. So there is only one network. This 128.56 means only one network. This is not contiguous. Single network only. And we cannot apply supernetting on single network. We cannot apply supernetting. Most of the students think like that 24, 25, 26, 27 contiguous. Yes. Array, this is class B yaar. Class B network ID 16-bit. Network ID must be contiguous. There is only one single network 128.56, 128.56, 128.56, 128.56. It is not contiguous. There is only one single network. Supernetting cannot apply on single network. Supernetting cannot apply on single network. On single network. For applying supernetting, we must have minimum 2 networks, then only we can apply supernetting. Is it clear? You can get this PDF from Telegram group. Okay. Is it clear? So can I move to next? Now. This is question number 4 that you can see on this screen. Question number 4. Tell me that. First rule we have to check. Contiguous. Contiguous true or not? Because it is class B na yaar. It is class B. Class B have network ID how many bits? 16 bits. Host ID how many bits? 16 bit. So we have to check 2. 128.56. 2 octet. 128.57. 128.58. 128.59. So whenever there is a class B network, so we have to focus on first 2 octet. First 2 octet. And we have to check second octet for continuity. If we have class C, so we have to focus on first 3 octet, but we have to check for continuity last 3rd octet. Okay. I hope you got the point. Okay. So it is class B na. So we have to focus on only on first 2 octet. And for continuity, second octet. 56, 57, 58, 59. Yes, correct. True. If it is true, what is the second rule? Same size. Yes, same size. Yeah, it is class B na. So this host ID 16-bit. This 16-bit host ID. How many IP address in this network? 2 power 16. In this network, 2 power 16. In this network, 2 power 16, 2 power 16. Same size, yes, true, 2 power 16. And number of networks? 4. This is nothing but 2 power 2. Is it clear to everyone? Now, can I move to next? What is the third rule? First network ID must be divisible by total size of supernet. So let me focus on total size of supernet. Total size of supernet. Total size of supernet. So this is nothing but 2 power 16 plus 2 power 16. 4 network plus 2 power 16 plus 2 power 16. So this is nothing but we can say 4 into 2 power 16. 4 into 2 power 16. So this is we can say 2 power 18. It is really very simple. Okay. Now first network must be divisible. First network must be divisible by 2 power 18. Yes. 128. Let me check. 128.56. 128, 64. 32 plus 16, 48. Plus 8, 56. 4, 2, 1. After that, 1, 2, 3, 4, 5, 6, 7, 8. Again that 1, 2, 3, 4, 5, 6, 7, 8. If I divide this by 2 power 18, so last 18 bits represent remainder. Last 18 bits represent remainder. Yes, last 18 bits represent remainder. Or host ID, remainder or host ID. Or 18 bits are 0. So it means third rule also true. If third rule also true, so we can apply supernetting. So what will be the supernet ID? Supernet ID is nothing but first IP address. Supernet ID, first IP address. First IP address will be 128.56.0. Anyone can tell me the supernet mask? Supernet mask, can you tell me supernet mask? Supernet mask. Supernet mask depends on total size of supernet. So yeah, total size of supernet, how much? Total size of supernet. This is nothing but 2 power 18. If total size of supernet 2 power 18, so host ID how many bits? 18 bits. So network ID how many bits? 32 minus 18. This is nothing but 14 bit. So supernet mask have 14 ones. Supernet mask have 14 ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Again 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Now this is 255.252.0.0. Is it clear to everyone? Is it clear to everyone? Question number 4. So can I move to next question? If is it clear to everyone, so can I move to next question? Tell me that. So I will move to next question. Yes sir, very good. Now my dear friends, I want to tell you some difference between subnet mask and supernet mask. Okay, and later we will solve some question. Subnet mask, supernet mask. In the subnet mask, default subnet mask, you know one thing, that class A, it is better that if I write one thing. Class A default subnet mask 255.0.0.0.0. Class B, this is 255. This is really very important table because they can ask a question from this table. Class C, 255.255.255.0. So in this default subnet mask, class A have network ID how many bits? 8 bits. So 8 ones. Class B network ID how many bits? 16 bits, minimum 16 ones. Class C network ID how many bits? 24 bits, minimum 24 ones. So in the subnet mask, number of ones either equal to the network ID part or greater than the network ID part. Same I have written, number of ones in the subnet mask either equal to network ID bits or more than network ID bits. In subnet mask, either number of ones equal to the network ID bits or greater than the network ID bits. Is it clear? This point, subnet mask, number of ones either equal to the network ID bits or greater. If we have greater, so it means we have taken borrow from host ID. But in the supernet mask, it is different. Let's see. This is the supernet mask now for class. So this is the supernet mask for which class? Class C. This example we have seen now, class C. Supernet mask for class C. What is this? 255.255.252.0. This is class C supernet mask. It means number of ones how many here? Class C network ID 24 bits. Class C network ID how many bits? 24 bits. But number of ones how many? Less than, na? Number of ones how many? 8 plus 8, 16, 16 plus 6, 22. Number of ones less than. Are you getting my point? So in the subnet mask, number of ones either equal to network ID or greater than the network ID. But in the supernet mask, this supernet mask is for class C. Class C have network ID 24 bits, but number of ones how many? 22. So in the supernet mask, the number of ones always less than the network ID bits. Is it clear? Number of ones always less than the network ID bits. Same things I have written. Number of ones in the supernet mask always less than network ID bits. This table is really very important, my dear friends. Now, subnetting is applicable only for single network. We divide single network into multiple subnet. So subnetting is applicable only for single network. Now, supernetting is applicable for two or more network. On single network, we cannot apply supernetting. This is the point number 2. Point number 3. In subnetting, we borrowed from host ID. In subnetting, we always take borrow from host ID part. In supernetting, we borrowed from network ID. Supernetting, we always borrow from network ID. Is it clear to everyone? No, it is not case of class C. Yeah, in this, it is not the case of class C. You can take this class B also example, class B. This is, listen me. This is the supernet mask now for class. This is supernet mask. Yeah. For this, for which? This is class B na? Class B supernet mask, how much? 255, 252.0.0. How many ones in the supernet mask class B? 8 plus 6, 14 ones. But in the class B, network ID, how many bits? 16 bits. So less than the network ID or not? So it does not matter that class A, class B, class C. It is a general statement. In the supernet mask, number of ones always less than the network ID bits. I hope you got it. Okay. Now, suppose my dear friend, this address is given. 255.0.0.0. Now we have to check that this address for class A, it can be used subnet mask or supernet mask. For class B, it can be used subnet mask or supernet mask. For class C, it can be used subnet mask or supernet mask. Let me finish up. Okay, so 255.0.0.0. In this address, how many ones we have? Listen me carefully. How many ones we have? 8 ones. 8 ones. So class A have network ID how many bits? 8 bits. So it means in the subnet mask, this is the default subnet mask for class A. So class A definitely it will be used for subnet mask. If number of ones are 8 equal to network ID or greater than the network ID, so it can be used for subnet mask. You have to check only for number of ones. If number of ones equal to network ID or greater than network ID, so it is used for subnet mask. If number of ones less than the network ID bits. So it is used for supernet mask. So this address for class B, because class B network ID how many bits? 16 bits. How many ones we have? 8 ones. So number of ones are less than the network ID bits. If number of ones are less than the network ID bits, so definitely it will use for supernet mask. So that's why for class B it is supernet mask. Is it clear? Now, number of ones 8. Class C network ID how many bits? 24 bits. If number of ones less than the network ID bits, so it means it can be used for supernet mask. Number of ones 8. Network ID of class C 24. So that's why it is used for supernet mask. First row it is clear to everyone. So I can move to next. Now 255, 255, 252. How many ones we have? 8 plus 8, 16. 16 plus 6, 22 ones. 22 ones. Class A subnet mask. Class A network ID how many bits? 8 bit. If number of ones are equal to network ID or greater than network ID, it will be used for subnet mask. Yes, number of ones how many? 22. Greater than network ID. So definitely it will be subnet mask. That's why it is subnet mask. Class B network ID how many bit? 16 bit. If number of ones equal to network ID or greater than, so this is nothing but subnet mask. So that's why for class B it is subnet mask. Class C network ID 24 bits. If number of ones less than the network ID bits, this is nothing but for supernet mask. So this will be used for supernet mask. Is it clear now? How many ones we have in this? 24. 24 ones. Class A network ID how many bits? 8 bit. If number of ones equal to network ID or greater than, so it will be used for subnet mask. So that's why subnet mask. Class B network ID how many bits? 16 bit. Number of ones are equal to network ID or greater than, it means subnet mask. That's why subnet mask. Class C network ID 24 bits. So number of ones less than the network ID. So it will be used as a supernet mask. This is clear or not? So this type of question they may be asked in the exam. Is it clear? Now I can move to question number 5. This is question number 5. Some questions I have given as a homework, but I have included in this here. Okay, all these questions which I have given you as a homework, I have included here. A company needs 600 addresses. Which of the following set of class C block can be used to form a supernet for this company? A company needs 600 addresses. Following set of class C block can be used to form a supernet for this company. Anyone can tell me the answer here? Tell me the answer. What is the correct answer for this question? Here for 600 addresses, 2 power 9 is not possible. Na? 2 power 9 means 512. 2 power 10. 2 power 10. For 2 power 10, what we have to do? We have to combine 4 class C. This is class C, class C, class C, class C. 4 network of class C we have to combine. 4 network. 4 network of class C we have to combine. Okay. Because it have 2 power 8, it also have 2 power 8, it also have 2 power 8, it also have 2 power 8. So this is nothing but 2 power 10. Which one is the correct answer? Anyone can tell me? Correct answer for this question? Correct answer for this question. Let me show you first. First we have to check continuity, na? Continuous. So this is class C. Class C means we have to focus on third octet. First 3 octet. For continuity we have to focus on third octet only. 32. This is 33. After that it must be 34. But it is not contiguous. Wrong? Now 3 octet. Okay, for continuity we have to focus on only on third octet. 32. After that this is 42. Not contiguous. Wrong. 31. Yes. After that 32. Yes. After that 33. Yes. After that it must be 34. not contiguous, wrong. 32, yes. 33, yes. 34, yes. 35, yes. All are contiguous. Now, first rule is contiguous. Contiguous. It may happen that, my dear friends, it may happen that one of the option is not possible. Contiguous, true. What is the second rule? Same size. We have to check all the three rules. Same size, yes. Why it is same size? Class C, 2 power 8, 2 power 8, 2 power 8, 2 power 8. Because class C host ID how many bits? 8 bits. So number of IP address in each class 2 power 8, 2 power 8, 2 power 8. Okay. Same size 2 power 8. And number of networks also 4. Number of networks equal to 4. We can say 2 power 2. First network ID must be divided by total size of supernet. Total size of supernet. But in this question, no need to check this, but they can ask a question not possible. Total size of supernet 2 power 8 plus 2 power 8 plus 2 power 8. So further we have to check all the three conditions. This is nothing but 2 power 10. First network ID means 198.47.32.0. 198.47.32. 128.64.32. 16.8.4.2.1. 1, 2, 3, 4, 5, 6, 7, 8. 2 power 10. Last 10 bits represent remainder or host ID. Yes. It is remainder or host ID. It is remainder or host ID. Yes, all have 0 in the host ID part. This is also true. So it means we can combine. Okay. Chalo. So correct answer for this question will be D. Now let's move to the question number 6. Consider 4 network this one and perform CIDR aggregation to select one of the following supernet mask. So anyone can tell me the correct answer? This is question number 5. Tell me the correct answer of question number 5. Question number 5. This is 199.200.0.0 199. It is class C na yaar. Class C. So class C means first 3 octet. For continuity, we have to focus on only on third octet. 0, 1, 2, 3. Yes. Okay. Continuous. Yes. First rule, but this is contiguous. True. What is second rule? Same size. Yes. Same size is also true. Same size and number of networks 2 power 8. And number of networks is also 4. Number of networks 4. We can say 2 power 2. Okay. What is third rule? First network ID must be divided by total size of supernet, because in this we have none of these answer also. So it may that supernetting is not possible. So first network ID must be divided by total size of supernet. What is total size of supernet? What is total size of supernet? So we have 2 power 8, 2 power 8. How many networks we have? 4 networks. This is network 1, network 2, network 3, network 4. Network 1, network 2, network 3, network 4. And all have 2 power 8 size. We can say 2 power 8 plus 2 power 8 plus 2 power 8 plus 2 power 8. So this is nothing but we can say 4 into 2 power 8. So we can say 2 power 10. Okay. First network ID must be divisible. This is nothing but 199.202.1234567 1234567 This is 2 power 10. Yes. Last 10 bits represent remainder. So it is true or not? Remainder or host ID we can say. Remainder or HID we can say. Yes, true. So this is also true. Okay, so what they're asking? They're asking only supernet mask, and supernet mask depends on total size of supernet. तो यार total size of supernet how much? 2 power 10. Total size of supernet. Total size of supernet equal to 2 power 10. So it means host ID how many bits? 10 bit. Host ID equal to 10 bits. So what is the network ID? Network ID is nothing but 22 bits. 32 minus 10. 32 minus 10. This is nothing but 22 bits. So this is nothing but 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is nothing but 255.255.252.0. But if none of these is not available, sometimes it may happen that they can ask none of the, because this D answer may be correct. Why? Because supernetting is not possible. So we have to check all the 3 conditions. For safer side, we have to check. Otherwise, simply we can solve there. This is 2 power 8, 2 power 8, 2 power 8, 2 power 8. Total size of supernet 2 power 10. If total size of supernet 2 power 10, host ID 10 bit, network ID 22 bits, it means supernet mask have 22 ones. But why I have done this? Because we have to check all the 3 conditions are satisfied or not. Is it clear? Question number 7. This is 255.255.252.0. Can probably be used in class A, class C and class B. So first of all, we have to convert this. How many ones here? This is the mask. So mask equal to how much? 255.255.252.0. So yeah, we have here how many ones? 8 ones, na? This is 8 ones plus 8 ones plus 6 ones. So this is nothing but 22 ones. So class A, network ID how many bits? 8 bits, na? So number of ones are greater than, if equal to network ID or greater than network ID, so it is used for subnet mask. So class A, this is nothing but for subnet mask. Class C, because they are asking class A, class C. Class C, network ID how many bits? 24 bits. But number of ones how many? 22. Less than the network ID. If less than the network ID, it happens in the supernet mask. So this will be used as a supernet mask for class C. Supernet mask. Okay. Class B, network ID how many bits? 16 bits. Number of ones how many? 22. If number of ones equal to network ID or greater than the network ID, this is used for subnet mask. Subnet mask. What they are asking? Listen me. Class A. Class A. After that, class C they are asking. Class A, class C, class B. Class A, subnet mask. Class C, supernet mask. Class C, supernet mask. Class B, subnet mask. So option A is correct. A is correct. A. Because first they are not asking in the sequence class A, class B, class C. They are asking class A, class C, class B. Clear? Now, this is question number 8 that you can see on the screen. In class C, if supernet mask is this one, then number of class C network combined to form supernet is. This is question number 8 that you can see. Question number 8 that you can see. Question number 8. If supernet mask is 255.254.0, then number of class C network that can be combined. Here class C they are asking first of all. Supernet mask 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 224, 1, 2, 3. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is supernet mask. Anyone can tell me the answer here? In the supernet mask, number of ones must be less than the network ID bits. Yeah, tell me one thing that class C na, class C. What is the subnet mask? Subnet mask 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. We know this thing now. This is network ID and this is host ID here. In supernetting, we take borrow from network ID part. We take borrow from network ID. In subnet mask, whenever we take borrow from host ID, na, so these bit will be 1. In subnet mask, borrowed bit will be 1, but in the supernet mask, borrowed bit will be 0. Because class C have 24 ones na minimum. But how many ones we have? So these 5 bits are nothing but supernet bits. Supernet, because we take borrow from network ID. Supernet bits, how many here? 5. A is not correct answer. Supernet bits, how many? 5. So number of networks that can be combined. Number of networks that can be combined. That can be combined. Equal to 2 power 5, because this is nothing but 32. If a supernet ID 5 bits, so number of networks that can be combined, this is nothing but 2 power 5, 32 bit, 32. So correct answer for this question will be B. Is it clear to everyone? Question number 8 is clear to everyone, so I can move to next question, my dear friends. Question number 8 is clear to everyone, so I will move to next question. Now this is question number 9 that you can see. Question number 9. Question number 9. Let's see the question number 9 and try to solve question number 9. Please. Now, it is really interesting question here. Actually, what is my concern always? My concern always is if you will attend my session, it will be a value addition. Okay, it will not like that wastage of time. You will get some concept and some good quality of questions. Okay, now what is given here? If default subnet mask for network 255.255.255.0, default subnet mask, here subnet mask is given here. What given? Subnet mask 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. Okay, so this is default subnet mask for which class? This is default subnet mask for class C. So class C have network ID how many bits? 24 bits. Host ID how many bits? 8 bits. This is host ID. Okay, now what is given here? If m bits are borrowed from network ID, if you are taking m bits from network ID, then what could be the supernet mask? They are saying that if we take m bit borrowed from network ID, so this is nothing but supernetting concept, because in the supernetting we take borrow from network ID part. So these options are given. How we can solve? We can solve these options. We can solve this question by taking with the help of option. Because it is given 255.255.2 power 8 minus m minus 1 into 2 power m dot 0. Third octet value this one. 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 Suppose m bit borrow na. Suppose I am taking m equal to 4. I am taking 4 bit borrow from network ID. 4 bit borrow from network ID. So what will be the supernet mask? Let me show you. Supernet mask. So this will be 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. If I take 4 bit borrow, so it means network ID means 4 bit. If I take borrow, so it will be like that 1 2 3 4 1 2 3 4 1 2 3 4 5 6 7. If I take 4 bit borrow from network ID means last 4 bit I will take borrow. So it means these 4 bits are nothing but supernet bits. Okay, supernet bits. So this will be the condition of supernet mask, na yaar. If this is subnet mask, if I take 4-bit borrow, is it fine? So we have 21s in the supernet mask. If I convert into 0 and 1, so what it will be? 255.255.240.0. So in all the options, first two octets are 255.255, 255, 255, 255, 255, 255, 255. Last octet also dot 0, dot 0, dot 0, dot 0. We have to focus on only on third octet. Third octet. We have to focus on third octet only. So let's take option one by one. Option A. What is saying that? 2 power 8 minus m. 2 power 8 minus m minus 1 into 2 power m. So m value is nothing but we have 4. So 2 power 8 minus 4 minus 1 into 2 power m value is 4. 2 power 8 minus 4, 4. 2 power 4, 16. 16 minus 1, 15. 15 into 2 power 4, 16. 15 into 16, 240, 240, 240. Yes. Because in this supernet mask, third octet value is 240. Third octet value is 240. So if I take option A, so this third octet value will be 240. A will be the correct answer. If you want to check B option also, what is B? 2 power 8 minus m and into 2 power m. 2 power 8 minus 4 into 2 power 4. So 2 power 4 kitna? 8 minus 4, 4. 2 power 4. 2 power 4, 16. Into 2 power 4, 16. This is 256. But third octet value is 240. So this is wrong here. If I take option C here, 2 power 8 minus m minus 1. 2 power 8 minus m minus 1 and into 2 power m minus 1 into 2 power m minus 1. So you have 2 power 8 minus 4 minus 1 into 2 power 4 minus 1. So 2 power 5, 2 power 3. It will be 2 power 3 into 2 power 3. 2 power 3, 8. 8 into 8. 64. But third octet value is 240. So C is also wrong. So that's why D will also be wrong. D I am directly putting 2 power 8 minus 4 into 2 power 4 minus 1. So you have 2 power 4, 16 into 2 power 3, 8. This is nothing but 128. But this value is 240. So correct answer is A. Is it clear to everyone? This question number 9 is clear to everyone. Can I move to question number 10? Tell me. It is really very interesting question here. It is really very interesting question. I am putting this star. What is given in the question? Let's see. You can take, Soumya, you can take. If you take here 8, you can take 5, you can take any number you can take. But what, if you are choosing m value 4, so you have to put m value 4 here. If you take m value 6, you have to put m value 6. Definitely you will get the option A. It is not the case that whatever you can take, it does not matter. I am putting this star. What is question? One of the IP address of Supernet is given as 201.99.89.113 and Supernet mask 255.255.255.0. What will be the range of Supernet? One of the IP address given, Supernet mask given. What will be the range of Supernet? What will be the range of Supernet? So yeah, it may happen that we are combining 4 network. We are combining 8 network. We are combining 2 network. What is the meaning of range of the Supernet? Range of the Supernet means first IP address. Suppose we are combining 4 network. First IP address of first network and last IP address of fourth network. They are asking entire Supernet. Suppose we are combining 4 network. So first IP address of first network and last IP address of last network. They are asking. I hope you are getting my point. So actually, my dear friends, finding the first number is really very simple. How we can find the first number? First number is nothing but first IP address is nothing but Supernet ID. Finding the Supernet ID is really very simple. How we can find? If you take IP address, apply the bitwise ending with the Supernet mask, so we'll get Supernet ID. IP address ending with subnet mask, we get subnet ID. So if we have IP address and we have Supernet mask, If we apply bitwise ending, so definitely we will get supernet ID. So first IP address is really very simple to find. If I take this IP address, apply the bitwise ending with the supernet mask. This is really very interesting question. Maybe in this 2023, this type of question they can ask. So this is nothing but supernet ID. IP address. What is IP address given here? 201.99. 201.99.89.113. Now, supernet mask, what is this? 255.255. Supernet mask 252. So this is nothing but 201.99.113.00. Anyone can tell me 89.252. 89.252. It will be 88. Those who are feeling confusion, let me show you here. 89 bitwise ending with 252. How? 128, 64 plus 32, 0. 64 plus 16, 80 plus 8, 88, 4, 2, 1, 89. 252 means 255 minus 3. Last 2 bit will be 0 and remaining will be 1. So this is nothing but 0, 1, 0, 1, 1, 0, 0, 0. So this is 64 plus 16, 80 plus 8, 88. Do not get confused. We have many methods here. We can easily find this 89. How we can write? 64 plus 32. Sorry. 64 plus 16, 80 plus 8, 88 plus 1, 89. 252, how we can write here? 128 plus 64 plus 32 plus 16 plus 8 plus 4. What is common here? This is 64 plus 16 plus 8. 64 plus 16 plus 8. 88. Okay. Clear? Now let me solve. Anyone can try. Supernet mask is given here 252.0. Supernet mask. Now we can solve this question. Supernet mask. It is really very interesting question, yeah. 255. It is better that 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now what is given here? 252.0, yeah. 252.0. 252 means 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Okay. Now tell me one thing that yaar, class C na? Class C. Network ID bits. This is class C na? 200 class C. Network ID how many bits? 24 bits. Host ID how many bits? 8 bit. So it means last 8 bits are representing host ID part. My dear friends, actually class C subnet mask how many ones? Minimum 24 ones. In the supernetting we take borrow from, because minimum ones how many in the subnet mask? 24. But here how many ones we have? 22 ones. So it means these 2 bits we are taking borrow. So these 2 bits are nothing but supernet bits. These 2 bits are nothing but supernet bits. Supernet bits equal to 2. So number of networks that can be combined. Number of networks that can be combined. That can be combined equal to 2 power 2. 2 power 2 yani 4. 4 network can be combined. How it is? Yeah, these 2 bits are supernet ID na. So actually we have 2 bits. How many combinations we can make? 4 combinations. 0 0 0 1 1 0 and 1 1. Suppose this is network 1, this is network 2, this is network 3, this is network 4. So we have 4 networks here. Now we have to find the range of this 4 network also. Range, how we can find? 201.99. Now let's see. 201.99. Now this last 2 bits are representing supernet bits. Let's focus on third octet. Third octet is given 89. Convert into 0 and 1. 128, 64, 1. 32, 0. 64 plus 16, 80. Plus 8, 88. 89, 88. Okay. 8, 4, 0. And last 2 bits, leave it. 1, 2, 3, 4, 5, 6, 7, 8. No need to convert the entire number into 0 and 1 because last 2 bits are representing supernet ID. So in this, we know one thing that, my dear friends, it is really interesting question. This is representing host ID part. These 2 bits are representing supernet bits. Supernet ID. Supernet ID. Or supernet bits. Supernet bits. Is it clear? Now actually we have 4 networks, N1, N2, N3, N4. Now we can find the range of N1, N2, N3, N4 network or not? What will be the range of N1? Now how we can find N1? 201.99 010110 010110 010110. Okay. For N1 network, first 2 bits will be 00. For N1 network, first 2 bits will be 00. So for N1 network, this first 2 bits will be 00. Dot. And this entire represent host ID part. What is the first combination of host ID? Put all zeros in the host ID part. So now I'm taking all zeros in the host ID part. All zeros in the host ID part. 1, 2, 3, 4, 5, 6, 7, 8. Now tell me one thing, that what is the last number of network 1? Last number of network 1, 201.99.010110. Okay. And this 00 will be fixed now. Last number means put all ones in the host ID part. Put all ones in the host ID part. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now tell me, what is the first number? First number is nothing but 201.99. This is 64 plus 16, 80. 80 plus 8, 88. 88.0. Last number 201.99.88.255. Is it clear or not? Tell me. Is it clear or not? Now same as it is, can I find the range of N2 network? Can I find the range of N2 network? Yes, sure, why not? Now N2 201.99.010110. Okay. Now N2 network first 2 bits will be 01. So these 2 bits will be 01. And first combination, put all host ID bits 0. 1, 2, 3, 4, 5, 6, 7, 8. This is or not? Yes, sir. Last number 201.99. 201.99.010110. Okay. And these 2 bits will be 001. Same, not difficult at all. Now, what the last number? Last number means put all ones in the host ID part. 1, 2, 3, 4, 5, 6, 7. Okay. Now this is 201.99. This is 64 plus 16, 80 plus 8, 88, 88 or 1, 89.0. Or last number, this is 201.99.89.255. This is or not? So can we find N3 network range? Can we find N3 network range? Zero one zero one one zero. 010110. It is really interesting question, yeah. N3. First 2 bits will be 10. First 2 bits will be 10. First 2 bits will be 10. First number put all zeros in the hostility part. 1, 2, 3, 4, 5, 6, 7, 8. Now, last number. 201.99.010110. It will be fixed. Now this is 10. All ones in the hostility part. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now this is nothing but 201.99 dot. It is 64 plus 16, 80 plus 88, 88 plus 2, 90, 90.0. And last number 201.99.90.255. Is it clear? Now, can anyone tell me the N4 network? N4 network 201.99.010110. N4 network last 2 bits will be 11. First number put all zeros in the hostility part. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now 201.99.010110, and these last 2 bits will be 11. Last combination, put all ones in the hostility part. Put all ones in the hostility part. 1, 2, 3, 4, 5, 6, 7, 8. So this is nothing but 201.99 dot. So this is 64, 16, 80, 88, 90, 91, 91.0. And last number, this is nothing but 201.99.91.255. So anyone can tell me which is the correct answer? They are asking range. What they are asking? They are asking range, my dear friends. Range means first IP address of first network. 201.99.88.0. 201.99.88.0. And last IP address of last network, this is 201.99.91.255. So this will be the correct answer. So which one is the correct answer? Which one is the correct answer here? 88.0, 88.0 to 91.55. B will be the correct answer. B will be the correct answer. Question number 10 is clear to everyone? Now, let's move to the question number 11. Question number 11. In class C, if supernet mask is 255, 255, 252.0, how many number of networks that can be joined? And this is for UER. It is really very simple. What they are saying, class C. Class C. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 252. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Class C means network ID how many bits? 24 bits. Subnet mask minimum how many ones? 24 ones. But here we have less than 24 ones. So it means we have taken borrow from network ID. How many bits? These 2 bits are, because class C network ID how many bits? 24 bits. No? So supernet bits how many? Supernet bits equal to 2. So number of network that can be combined, इक्वल टू 2 पावर 2 यानी 4. सो दोस्तों इसका आंसर कितना होगा 4. इज इट राइट? क्लियर? क्लियर? Okay. So this is regarding the supernetting class, my dear friends. Okay, so we have covered till now, we have covered the IP addressing, subnetting and supernetting, and all type of questions I have covered. Okay, so definitely these two classes will be the value addition in your gate preparation. Okay, so my target is that all the compute network will be revised through questions, and I have arranged all the questions in such a way that all the concept of IP addressing, subnetting, supernetting will be revised. This is my main motto only. Okay. Last wala supernet mask. This is supernet mask na yaar. Class C network ID how many bits? 24 bits. If number of ones are less than network ID, so this is nothing but we have taken borrow from network ID. Because number of, in this subnet mask default how many ones? 24 ones na, but how many ones we have? 22. So it means if number of ones are less than 24, so we have taken borrow. So these 2 bits we have taken borrow. Supernet bits 2 already I have discussed. Okay, so tomorrow you have another session, and tomorrow we will discuss flow control and error control topic. Okay, flow control and error control, and I also have arranged the flow control, error control questions also in such a way that your all concept will be revised of flow control and error control. So thank you so much for attending the session. I will meet you tomorrow same time 4 p.m. Thank you. Bye bye.